Good morning, everyone. Our group assignment is on the topic of limits. My lecturer for this topic is TS Dr. Gede. We have 4 group members. My name is Siti Nur Aisyah binti Muhammad Amir Bakir, and the second is Nurul Madeha binti Syabki. The third is Azmira Izani, and the lastly is Aina Elisha binti Zaidi. To give you a better understanding of how we approach solving limit calculation, let us take you through our step-by-step process and the strategy we use. Let's go. Assalamualaikum and good morning everyone, and my lecturer Segede. My name is Siti Nur Aisyah binti Muhammad Amir Bakir, nama matrik DB240152. Today, I want to present about Part A concept review. The first is about definition of a limit. What about definition of a limit? Okay. The first is a limit describes the value of function f open x close bracket approach as its input x gets arbitrarily close to a specific point C. It focuses on the behavior of the function near that point, not necessarily its actual value at the point. Limits help us analyze functions with gaps, jumps, or undefined values. They form the foundation of calculus, especially for derivative and continuity. That's all for me. Thank you.
One-side limits. A one-side limit consider a function behavior when the input approach number from only one direction, either from the left, x divide to a minus, or from the right, x divide to a plus. These limits are essential when studying functions with step change or difference definition on each side of a point. A two-side limit exists only both one-side limits exist and are equal.
My name is Aina Elisha binti Zaidi, number matrik DB240064. Infinite limits. Number 3. An infinite limit occurs when the output of a function increases without bound, positive infinity, or decreases without bound, negative infinity, as the input approaches a specific number. Infinite limits typically appear near vertical asymptotes, indicating that the function grows extremely large in magnitude rather than settling at a finite value. 4. Limit laws. Limit laws are algebraic rules that allows limit to be evaluated by breaking a function into simpler components. They apply to sums, differences, products, quotients, and powers provided each component has a limit. These laws streamline calculation and enable us to evaluate complex limits efficiently and systematically.
The lastly is about squeeze theorem. The squeeze theorem states that if a function is trapped between two other functions that both approach the same limit, then the trapped function must approach that limit as well. This theorem is powerful for resolving limits involving oscillation or complicated expression, especially when direct substitution is impossible. That's all for me. Thank you.
Limit problem number 3. Evaluate the limit as x approaches infinity of the quantity 5x squared minus x plus 1 divided by 2x squared plus 7 divided by x squared open parenthesis 5 minus 1 over x plus 1 over x squared close parenthesis divided by open parenthesis 2 plus 7 over x squared close parenthesis. The limit equals 5 over 2.
numerator
x.
becomes
Limit
2.
problem number 3.
Problem 2,
Evaluate the
we
limit
evaluate
as
the
x
limit
approaches
as x
infinity
approaches
of
0
the
of sin
quantity
x
5x
x.
squared
This
minus
is
x
well-known
plus 1
standard limit
divided
in
by
calculus.
2x squared
As
plus
x
7
gets
divided
closer to
by
0,
x squared
the sin x
open
divide x
parenthesis
approach
5
1.
minus
So the
1
answer
over
is
x plus
simple
1
1.
over x squared close
Question 2.
parenthesis divided
Evaluate
by
the
open
limit
parenthesis
sin x
2 plus
divide
7
x.
over x squared
From
close
problem
parenthesis.
2,
The limit
we evaluate
equals
the
5
limit
over
as
2.
x approach 0 of
Limit
sin x
problem
divide
number
x.
3.
This
Evaluate
is
the limit
well-known
as
standard
x
limit in
approaches
calculus.
infinity of the
As x
quantity
gets
5x
closer to
squared
0,
minus x
the
plus
sin
1
x divide
divided
x
by
approach
2x
1.
squared
So
plus
the
7
answer
divided
is
by
simply 1.
x squared open
Question 2.
parenthesis 5
Evaluate
minus
limit
1 over
sin
x
x
plus 1
divide
over
x.
x squared close
From
parenthesis
problem 2,
divided by open
we evaluate the
parenthesis
limit
2
as
plus
x
7
approach
over
0
x
of
squared
sin x
close
divide x.
parenthesis.
This
The
is
limits
well-known
equals
standard
5
limit
over
in
2.
calculus. As x
Limit
gets
problem number
closer to
3.
0,
Evaluate the
the
limit
sin
as
x
x
divide
approaches
x
infinity
approach
of the
1. So
quantity
the answer
5x
is
squared
simply 1.
minus x plus 1
Question
divided
2.
by 2x
Evaluate
squared plus
limit
7
sin
divided
x
by
divide
x
x.
squared open
From
parenthesis
problem
5
2,
minus
we
1
evaluate
over
the
x
limit
plus
as
1
x approach
over x
0
squared
of sin
close
x divide x.
parenthesis divided
This
by
is
open
well-known standard
parenthesis
limit
2
in
plus 7
calculus.
over x
As
squared
x gets
close
closer to
parenthesis.
0.
The limits
Question 5.
problem number
Use
4.
the
The first one
squeezer
is
theorem to
evaluate the
evaluate
limit
lim
as x
square root
approaches
sin
2
1
from the right
divide
of
x.
1 over x
For the
minus
last
2.
problem, we need
Next,
to
as
evaluate the
x
limit
approaches
of
2
x
from the
square
right,
root
the
sin 1
denominator
divide
tends to
x.
0 from the
As
positive
x
side. Then
approach
the
0,
expression
we
goes
use
to
the
positive
squeezer theorem.
infinity.
We
There
know
is a
that
vertical
sign is always
asymptote
between
x equals
negative
2.
1
That's
and
all for
1.
me. Thank you.
So,
Limits
by
problem
the
number 4.
squeezer
The first
theorem,
one is
the limit
evaluate the limit
equals
as x
to 0.
approaches 2 from
Hi, my name is Azmira Izani binti Azmarif. Today, I would like to talk about real-world example with calculation. Okay, so about instantaneous speed. Instantaneous speed is a key concept in physics and is one of the most common real-life example of how limits and differential calculus are applied. So the first one is how limits are involved in this situation. In physics, the average velocity of an object over a certain time interval is found by taking the change in the object position and dividing it by the change in time. But to determine the instantaneous speed, the object's velocity at a precise moment, the time interval must become extremely small, approaching 0. Since dividing by 0 is not possible, we rely on the idea of a limit. Instantaneous velocity is therefore defined as the limit of the average velocity as the time interval approaches 0. And the second one is about what the limit represents. The limit gives the exact rate at which the object position is changing at that particular moment, which is velocity. First, geometrically, this limit corresponds to the slope of the tangent line to the position time graph at that specific point. And second, about physically, it represents the instantaneous velocity of the object at that moment. And third one is example of a calculation using a limit. Okay, so the problem that we have is an object is dropped and its position in meters as a function of time in second is described by a position function. So first we need to find the instantaneous speed of the object at a given time. So the solution is we apply the limit definition of instantaneous speed. First, we substitute the given position function into the expression. And second, we insert it into the limit formula for velocity. Third, we simplify the numerator. And fourth, factor from the numerator. And last one is we evaluate the limit.